This video is about limitations of optical microscopy, and I will explain why people had to invent more advanced microscopes, like for example the electron microscopes, to see more and more details down to single atoms. One thing that many students know is that the resolution limit is approximately a feature size of half the wavelength of the light we use as illumination source. That means that the smallest object we can analyze with a light microscope is around 200 nanometers. But why is that? The reason is diffraction, and diffraction occurs every time a wave encounters an opening, and the size of that opening defines how strong the wave will be diffracted. We can also think about this opening as a feature that we want to see in our image. Now, if these features or openings become too small, the light will be diffracted that much that our objective lens cannot capture the light anymore. And you can calculate the minimum feature size thanks to a bright mind called Ernst Abbe, who published the formula 150 years ago in 1873. This one is a little bit simplified. The real formula includes the refractive index n to account for different media and also the factor 2, because in a real microscope we are not limited to the on-axis illumination. And that is where the resolution limit for an optical microscope of half the wavelength of visible light comes from. But as always, there are exceptions, and maybe you heard about STED microscopy. It even was rewarded with the Nobel Prize in Chemistry 2014. And it is a special form of an optical microscope that is not limited to Abbe's resolution limit caused by diffraction. That is possible due to the sample that emits fluorescent light after it was excited by an external light source. But I will not go into the details here. If you are interested, Wikipedia gives a nice summary about how the technique works and why the resolution is even higher compared to other fluorescent microscopy techniques like the confocal microscopy. If that was a little bit fast for you and you want to repeat what diffraction is, then I recommend this video here to you. Or maybe you want to dive a little bit more into details, then I recommend the following website. All the links are in the description. And that's it. Thanks for watching the video, and see you in the next one.